Hi guys, today we're going to be discussing the Esaki effect and a little interesting thing that happens with it outside on the breadboard, okay? I'm going to draw it up here in schematic very fast here so that we can show you how to set it up. We're going to use a 1K resistor. We're going to use a power supply based off 12 volts, okay, DC voltage, and we're going to put in 12 volts. We're going to do this as quickly as possible here. Okay, hook that up. Let's turn that around. Let's see here. Let's turn that around so it's a little bit easier to hook this up. Okay, we'll rotate it just there and hook that up right there. I'm going to use an NPN transistor. So we'll go down here to transistors, NPN. Okay. We're going to rotate the transistor. We're going to mirror it. And we're going to rotate right, just like that. Okay. All right, so let's hook this up right to that leg. We're gonna have an LED come in, so light emitting diode. Let's bring it here. Notice the positive, right, to negative, and we're just gonna hook it up right there. And we need a capacitor, so let's go ahead and get the capacitor in here. Electrolytic capacitor. We're gonna use a 4.7 or 2220. In this case, we're going to use a 2220. 25 volts should be enough. Microfarad. And we're going to hook it up. And these two are going to be ground. So I'm going to get the ground port there so that way you don't get confused. Okay, I'll copy that. Put it over here. Okay, and this is your basic Esaki effect. So what's going to happen is the avalanche of the capacitor discharging from the resistor will overwhelm the breakdown voltage and will allow this to work, will allow it to continue. Here's one problem with the Esaki effect, and this is not really a problem. It's more of something that happens to it. And what happens with this leg here, the base? Well, because of the breakdown voltage and the avalanche coming in, a voltage seeping in through the, I believe this is... through one of the emitter here, and so we actually reverse this. So this should be the I think the collector here. I believe we're reversing it. Remember that. So the emitter is reversed. So a phenomenon that happens is this leg here. It's a very interesting phenomenon, and that can only be seen on an actual breadboard. And a lot of these circuit sims will not make the Esaki effect work anyways. It just will not work, and I'm going to prove it to you that it won't work. So I'm going to hook up this ground here all the way up to the 12 volt and finish this one up as well, so they're all being grounded. Okay, and it will not work. It works on a breadboard, but it won't work here. Okay, so you can see it just won't work. Well, that's because the circuit sim is expecting something to be hooked up to the base. And of course, there's nothing hooked up here, so it won't work. So nothing you can do here will make this work on any circuit sim. It just will not work. You can run it as long as you want. It's never going to work. Any circuit sim out there, I tried many of them. None of them work with the Esaki effect, okay? And now, the next part of the video is we're going to show you this effect live and what happens when we hook up a wire to the base, and we'll go do something with that base. That's going to be very interesting. All right, stay tuned. Be back in a minute. As you can see, this is the same arrangement as the diagram, as the schematic. Same thing. We have the LED on, the transistor, the NPN transistor, the 220 microfarad capacitor, and everything is hooked up to the way that it is on the schematic. And you can see I have the hooked up power ready too here. We are right now at 7 volts at 22 milliamps, and obviously you're not going to see the effect until I crank this up to 10.5 volts. That's the cutoff voltage. I'm going to increase it so that we are at 10.5. 9, we're getting to 10. I'm just adjusting the voltage power supply here. So 10.5, 10.5 is pretty good. I'm at 10.8, 10.78 volts. Okay, and now you can see the effect going. Here's an interesting thing that's going to happen now. Now I'm going to bring the voltage down just slightly until it stops. It's almost cut off. Okay, and I'm going to coarse tune the voltage down very slowly until you only see a little bit of the flash right there. That should be good. I'm going to take this lead here, this lead, and I'm going to put it on the base of the transistor. You see the base of the transistor here, right here? That's where I'm going to attach it on. Okay? And watch what happens here as you touch it. Okay? Try to get my fingers out of the way. Okay? Again, I'm just going to go off the board here so you can see it. So now I'm going to increase the voltage to 12 volts. Theoretically, that's what you should be at for the Esaki effect to start working. I'm going to increase it to 8.9, 9.2, and we're almost at 12. Okay, 12.08. Okay? Now I'm going to touch it again. Okay, do you see that? Very interesting effect.